A rare rock, blue asteroid, has some weird tricks doing strange things in the sky. Could this be the Hopi prophecies blue Kachina star? Well, guys, let me get into it. This is one of really capture your imagination. Being the only known asteroidal parent body of a meteor shower, the Geminids, Phaethon is already a peculiar asteroid due to its unusual blue color and comet-like behavior. What I told you I think some asteroids are burnout comets. Maybe this is one of them. At least it could be a water-bearing asteroid. I just did a video about an asteroidal ocean. Ragu. It's like a soup, ragu soup, spaghetti mix. I don't know. It is just the 11th known asteroid to exhibit a change in its rotational rate. So meteor showers typically come from comets. The Geminids, along with the quadratids, I hope I said that right, are the only meteor showers not originating from a comet. So we got two meteor showers that come from other sources. Phaethon, so named because it orbits closer to the sun than any other identified asteroid, was the son of the Greek sun deity Helios, which means the sun, basically, due to its size and inclination of its orbit, which I will show you in a bit. This does not represent a threat to Earth, but because it's considered a potentially hazardous asteroid, also known as a PHA, it does, as it does cross over Earth's orbit, but I'll show you why it's not a threat in a little bit. But because of these reasons, it is closely watched, of course, given that it's PHA. We watch all the PHAs. An asteroid seldom modifies its rate of rotation. With a diameter of 5.4 kilometers or 3.4 miles, Phaethon is the biggest of 11 known space rocks to accomplish this rotation change in its rate. It rotates once every 36 hours and has a highly precise inclined orbit. So this is what we know about this thing. And this is why, precisely why, we know it's no threat. It's the precision, the orbit, and the inclination. However, the most recent observations show that its orbital period, the period it takes it to orbit around the sun, is actually getting shorter by about 4 milliseconds per year. The Destiny Plus mission from the Japanese Aerospace Exploration Agency, also known as JAXA for short, kind of like NASA, short of National Aeronautics and Space Administration, is scheduled to fly past this asteroid in 2028, pretty soon. Therefore, learning Phaethon is speeding up could have significant effects for the craft's meticulously planned course. Sean Marshall, planetary scientist with the Arecibo Observatory, and by the way, the Arecibo Observatory broke, it fell apart, it crashed, and they're not going to repair it. It's never going to be operational again. But there is still science they have obtained from the observations up that they're still working out. And this is one of the things that they've just figured out from pouring through the data from the Arecibo Observatory. And I wish they would fix that. I mean, it's the world's largest radio telescope, but it is what it is. But anyway, so what he found, he was attempting to determine the size, the shape, and the rotation rate of Phaethon in advance of this mission using stellar occultations. And stellar occultations are, and light curve observations, similar to how we find exoplanets. Stellar occultations are when the asteroid passes in front of the star. See what's happening here? When an asteroid passes in front of a star, it's causing the light to dip. You see this? Now, the asteroid, and the star would have different apparent sizes because of changes in the orbit, and they can calculate how close they think it should be to total occultation. But you can see, as you can see from my crystal ball, as this blue orb passes in front of it, the light dips. Let's blur it on it. Well, this is actually my crystal ball lit up by my rocket Santa from behind it. A gift from the Blue Bottle Bunny Farm, Susan there. Anyway, for those of you that watch my Green Greg's channel. So anyway, Marshall developed a model using data from 1989 to 2021 that reveals that Phaethon is shaped like a top, just like the asteroids Bennu and Ryugu, which US and Japan have been to. Marshall was unable to make the most recent light curve reading from 2021 fit the model, though. The object has to be rotating at a constant rate, or it would be speeding up for the model to operate. So there we go. Marshall stated that the predictions from the shape model did not match the data. The times when the model was brightest were clearly out of sync with the times when Phaethon was actually observed to be the brightest. And he said, I realized this could be explained by Phaethon's rotational period, how fast it's spinning, changing slightly, and sometime before 2021 observations took place. And he says this is perhaps because of the comet-like activity when it was near perihelion in December 2020. Now, perihelion is when it passed closest to the sun, the closest. You know, an orbit, an object orbiting. Let's use a couple. I have another ball here. I got a little moon. This place, time. All right, we got Earth and a moon. So let's switch roles and let's assume that this is the sun and this is Phaethon. And when you got an orbit, you know, you get things go out and they come in typically. Most orbits are not nearly circular. You know, some of the planets in our solar system, fortunately, have very circularized orbits for the most part. And that's a good thing for our stability of seasons and such and so forth. Now, a lot of bodies do not have that, and they have a much more elongated orbit when they get past closer to the parent body and farther away. Apogee is when something's farther away from Earth. If farther away from the sun, is aphelion. You get close to the sun, it's perihelion. Para, close. Appa, apex, further away. So now a comet or any object that's got volatile materials in it, be it a carbonaceous chondritic asteroid, water-bearing asteroid, when it gets close to the sun, it's more likely to outgas some. Outgassing, let me hold the camera up. Outgassing outgassing is when the object is producing jets of vented volatile gases. Well, jets are kind of like rocket motors. They produce a little thrust, a little reaction mass. And so that could change either your spin, if enough, maybe the orbit itself. But, you know, an orbital body has a lot of momentum. It's easier to change the rotational rate than it is all that, the orbit itself. But the orbit itself is changing a little bit because we're noticing this the period is shortening by 4 milliseconds per year. And that's fairly significant, really, if it's just been done by jets. But the jets in themselves are interesting. So this is a comet-like behavior, which would comport with something that creates meteor showers. There you go, right? So that's how we know this, guys, and that makes it very interesting. Fortunately, for Destiny Plus, the mission from JAXA, they don't have to replan their goals in the mission. In fact, according to Marshall, this is good news because the team has a chance to predict Phaethon's orientation at the time of the planned flyby with a high degree of accuracy. They will also know which parts of the asteroid will be eliminated by the sun at that time, which should allow them to capture some breathtaking images of the asteroid as it passes by the surface. So there you go. So they got a good opportunity there. Let me do a little sharing here of some things here so you can see a little bit about this mission. What's interesting is, okay, if this thing actually is cometary, now think about, you know, we just had the DART impact into Didymos. Anyway, I'm getting confused here. Okay, guys, forgive me here. We just had the DART impact, and what happened when we had the DART impact? It caused a huge spray of material. It made the hit asteroid look like a comet. What if something hit this asteroid? What if it broke apart? We see asteroids are just flying robopiles quite often, and this may be the same thing. Dimorphos. Oh my God, I can't. I'm trying to go by memory. Dimorphos is going around Didymus. Dimorphos was the asteroid we hit. Yeah, tell me a second, guys. I'm not reading the script. I'm going by memory right now. So I'm going by memory. Dimorphos was hit, and it created a 6,000-mile long jet, guys. It actually had two tails, just like a comet. Just like a comet. It had the tail that that's going by the magnetic field from the sun, the other from the solar wind. So you got two tails. A comet has two tails. So that's highly interesting, guys. Dimorphos was hit. So Phaethon may be even more so like that. But of course, Phaethon gets closer to the sun than most asteroids. So that may be also why we're seeing this kind of activity out of Phaethon. Could Phaethon be, if it's got water inside, could it bear life? Why is it blue, for Pete's sake? That's the bigger question in my book. Why is it blue? So if this blue asteroid got struck by another asteroid, if just pieces of it come off because it's unstable from going around the sun at some point in the future and it breaks apart, as comets do sometimes going around the sun, could she flash up and produce a huge blue flare in the sky? Or it might be some other color because the materials inside might be different. But guys, that's entertaining. Maybe it did that in the past. Maybe that's where the Hopi got the idea of a blue Kachina. Or maybe this will happen yet. Of course, the sad thing is that in the Hopi prophecy, the blue Kachina is a sign of the end of days. Considering we're so near to potential nuclear war, one must ponder to wonder. Okay, I just want to share some sides here. Hang on, guys. Ding, ding, ding. Let's look at some other things here. I said I was going to show you the orbit. Here we are, guys. See, right now she's heading back out away from the sun. And we can turn this around and look at it different ways. I mean, you can see it crosses Earth's orbit, but it crosses above Earth's orbit in such a way that the Earth's going to be scooting underneath it, for the most part. So we don't believe there's any real true chance that it's going to hit the Earth. Now look at where it's flat, though it's a little different than where Earth's orbit's flat. Now, all the planets aren't exactly the same, are they? Or they would all line up perfectly when I do that. Either that or this model's off. So this is interesting. It goes really close to the sun, much closer than the planet Mercury, and comes back out toward the asteroid belt. So maybe it originated as an asteroid, maybe, possibly, or it could be something else. So this asteroid also might be maybe we'll intercept it one day and find out what it is. Why is it blue? So let's we can advance this and think when we're just going to be in the year 2030, because that's when some people think things are going to happen. So let's kind of just run this around. You see it going out. That's at aphelion. It's coming down. What year are we at here? We are at year 2023. Just swung around again. Now, see, that's what happens when you go out. They actually slow down. When they come near the sun, they speed up. Kepler figured this stuff out in about 1700, something like that. 2025. Coming around. This is a cool model because you can move things around. I should have sped it up. Well, look there. That's past near the Earth then. Maybe that would be an interesting time, 2027. The Earth was almost in the place it was. If it was to rupture then, that would make for a good sight. And right here it is again, close to Earth, right there, and 2028. You can see it passed right behind Earth in 2028. So there's several times it's going to pass right in front of behind Earth, and if it should rupture, now here's on the other side of the sun. There it passes in front of the Earth. So here we are, 2030. What's going to happen in 2030? Around, yeah, it's in front of Earth right there, good distance in front of Earth. But most likely to see something after, if it's going to flare, it must likely be after it passes behind the sun. So let's turn her back on. Yeah, Earth is some little distance away at this point. There we go. You'd almost have to look into the sun to see it there. So is this going to be a blue Kachina in 2030? I don't know, guys. I just picked 2030 because a lot of stuff's predicted to happen that year. But that's entertaining, guys. That's entertaining little thing to see. You look into the sun now. I don't think you're going to be seeing it at that point, but there were some other points where it was in front of the Earth in some of these previous rounds. So that's where you'd really expect. But coming in, you don't expect it to do anything. As soon as it's coming back out. So if you're somewhere right behind Earth, there was a few times when it's coming right back out, away from the sun, like right here. Let's just run back forward a little bit. Where am I at? No, I'm just run the other way. Oh, it's actually in front of the Earth in this pass. In front of the Earth after it passes the sun. And we're not having to look directly into the sun to see it. So as we swirl around and it goes out away from the sun, we might see if it's broken up like a comet. And this is the year 2029. Okay, that's entertaining. I think Apophis is supposed to pass close to us in 2029. This is in the month of August, August the 30th. Makes you want to type in Apophis, don't it? A-P-H-O, Apophis. Can I spell it? Was I close? No. All right, I'm an engineer. Don't accuse me of being a speller. Oh, well, we can look at that in a future video. Just getting curious here, but let's look at some other things. That was a little fun excursion. Here it is. Hey, I can get back at it from here. 3200 Phaethon. They show it rotating, guys, from the Arecibo Observatory. See, the Arecibo Observatory gets so many good asteroid images from that radio telescope. Potentially hazardous asteroid. If it did hit us, it would be catastrophic. It's so big, but it's blue. She's a blue. There it is, moving through the sky, I guess. Maximum angular velocity. Here it is moving. Oh, passing front star there. Passes front one there. There you go. That's the occultations we're talking about. So let's see if I type Apophis up here. If I get the spelling wrong, sometimes Wikipedia will tell you. Shoot. Forget it. Hang on to that today. It's the kind of thing your other shows would cut out and not send to you. The editor little faux pas, but I'm not going to edit it, guys. It is 10:37 my time. I'm doing good to get 4 hours sleep a night, which is really catastrophic for your health. So you get me raw. I'm raw but real. Anyway, so with that, we'll end with the astronomy pick of the day, guys. How about that? Wow, look at that. Milky Way and zodiacal light over Australia. Is that pretty or what? There we go. Let's blow it up. There we go. Whoa, we blew it too much. Wow, that's the kind of Stonehenge there. You know what? This is a lensatic effect. This is a fisheye kind of lens. This is a straight line over the sky, and this is probably one road, straight road. But she's a bit round due to the photographic effect here of the fisheye lens. All right, guys, let's stop the share. Like I said, forgive me for not editing my videos like a lot of other channels do, but guys, I'm an engineer. I work space stuff. You get a lot of other channels where this is all they do. They do YouTube and they talk, and you know they can clean their stuff up and make it, put in a lot of pizzazz. Occasionally, I may edit in some videos and stuff like that, but guys, it's tough. It is tough. But I gave you a cool story tonight. I gave you a cool story about a weird blue rock in the sky, an asteroid that acts like a comet. It's blue. What's it going to do? Well, it might be neat to see it break up and see what it would make. But let's hope it's not a harbinger of bad things, as Kachina was predicted to be. So with that, I'm going to say thank y'all for watching and have an awesome day, night. Greg out.